Matrix Transformations. Bottom of page 4 in the formula booklet gives me these two standard matrices, one for rotation, one for reflection. So looking at question 2, transformation T consists of an anti-clockwise rotation through an angle of theta about the origin. So that's the first transformation, which is that's described exactly as it's written here. So the first matrix that we got for the rotation then is cos theta minus sine theta, cos theta. And then the translation, right, now I know the translation has to be a 3 by 3, and the framework of that 1 0 0 1 0 0 1, and then my translation vector gets inserted in this right hand column here. So with the x, I'm adding 1.4 to the x, so and 1.8 to the y, so this is 1.4, 1.8. So those are the two matrices. Now then, the one that comes first has to be on the right hand side. So it's the rotation first, that has to be on the right hand side. Now then, I can't, because I got a 3 by 3, a 2 by 2 to multiply up, I need them both to be a 3 by 3. So the rotation, to make it bigger, we surround it with 0, 0, 1. So there's the 2 by 2, and then it's 0, 0, 1, 0, 0. So there's the 3 by 3. So that's the first thing I'm doing, is rotation. Then I do the translation. So the second thing I do is goes to the left of the first one. It's 1, 0, 1.4, 0, 1, 1.8, 0, 0, 1. And then to find T, then I multiply these matrices together. So it's T. So cross and down, the shape is also going to be a 3 by 3. It's going across and down. So cos theta, nothing, nothing. So that's cos theta. Then the second column, cross and down, minus sine theta, nothing, nothing. Finally the third column, nothing, nothing, 1.4. Second row, nothing, sine theta, nothing. Second column, nothing, cos theta, nothing. And finally, nothing, nothing, 1.8. And finally, the third row, the first column, nothing, nothing, nothing. Second column, nothing, nothing, nothing. And third column, nothing, nothing, 1. So there's matrix T, which gives me that transformation. That's part A. Part B, it's now telling me that T maps the point 1 0 to the point 2 1, find the value of theta. So when I operate this matrix, when I operate that on the coordinate 1 0, so the coordinate 1 0 goes there, but it has to be 3 entries in this column vector, otherwise I can't multiply. So we always finish off with a 1 as the third value. And when I operate that matrix on 1 0, I end up with the coordinate 2 1, so that goes down as 2 1. And again, to make it into a 3-rowed column vector, that goes, I need to add the 1 in there as well. So 1 0 is going to 2 1. Then if I multiply this out on the left hand side, so going across and down, so it's cos theta times 1, nothing times sine theta, and 1.4 times 1, so that's cos theta plus 1.4. In the second row, sine theta, nothing, 1.8 added together, so sine theta plus 1.8, then it's nothing, nothing, 1. And that equals 2, 1, 1. So this now gives me two equations. The top rows are equal, so cos theta plus 1.4 equals 2. And the second row gives me sine theta plus 1.8 equals 1. And the third line is 1 equals 1. So I'm solving these now. I want theta. So the top one will give me the cos theta, taking the 1.4 over is 0.6, and the second one gives me sin theta equals, and take the 1.8 over, that's minus 0.8. Now then, you have to solve, remember this is a rotation, it could be any angle, it could be anything from 0 to 360, so I need to solve both of these equations, cos theta equals 0.6, sin theta minus 0.8. I'll have two answers for each of them, and the theta that I want is the theta that's going to be common to both answers. So solving cos theta equals 0.6, so shift cos 0.6, that's 53.1, the first angle. Then the second angle for cos, from the cos graph, symmetry is about there, so if I go 0.6 in, first angle there is 53.1, the second angle, as we can see, is 360 minus 53.1. So those are the two possible angles when I'm solving cos theta 0.6, 53.1, or I'm taking 53.1 away, that's 306.9. So those are the two possibilities from the first equation. Then solve sin theta is minus 0.8. So if I just press shift sin 0.8, that's 53.1. So sin theta is positive 0.8, theta is 53.1. So I'll draw the sine graph. And put the values on. So I'm going to minus 0.8 from there, so my two answers are there and there. So positive 0.8 is 53.1, so that the value there is 53.1. So my two answers are 180 plus 53.1 and 360 minus 53.1. I can see the common angle. I have to do the same calculation here for the cos. Is going to be the second angle. Okay, this one is that's 233.1. So the angle I'm seeing twice is 306.9. Therefore, theta is 306.9 degrees. That's your rotation. And then part C is asking me show that T has a fixed point and find its coordinates. Well, fixed points are mapped onto themselves. Okay, so for the fixed points, I operate matrix matrix T, which is cos theta minus sin theta, cos theta, 0, 0, 1, 1.8, 1.4. When I operate that matrix on the coordinate xy, I need to put a 1 there because it's a 3 by 3 matrix. The answer that comes out is exactly the same as what went in, so that is also equal to xy 1. Now then we got the value of theta for the first part. I know it's 306.9, but I don't need to substitute for cos theta, just for theta, because I've actually got the values for what my cos theta and sin theta were. So I'm going to substitute in these values, cos theta and sin theta, here into the matrix. So cos theta is 0.6, sin theta is minus 0.8, So that's positive 0.8 there, minus 0.8 there. And then 0.1, 1.4, 1.8. xy1 equals xy1. Multiply out the left hand side, so crossing down, so that's 0.6x plus 0.8y plus 1.4. That equals xy1 second row minus 0.8x plus 0.6y 1.8. And the bottom line 0, 0, and I get 1 equals 1. So I've got two equations here, taking the top row, so 0.6x plus 0.8y plus 1.4 equals x. And the second row, minus 0.8x plus 0.6y plus 1.8 is equal to y. So I've got two simultaneous equations here, just tidying them up. The first equation, take the x over to the other side, so that's minus 0.4x plus 0.8y plus 1.4 equals 0. And the second one, taking the y over, minus 0.8x minus, take that's 1.2y, sorry, 0.6y minus y is 0.4y plus 1.8 equals 0. So just rewriting them in the structure we tend to see them as simultaneous equations, then I got minus 0.4x plus 0.8y equals minus 1.4 minus 0.8x minus 0.4y equals minus 1.8. So we make the y's the same, so I'll double the second equation. So the first equation stays the same. Doubling the second one, that's minus 1.6x minus 0.8y equals minus 3.6. And then I got the same coefficient of y, the opposite sign, so I just simply add up the two equations. So minus 0.4 minus 1.6 is minus 2x. And on the right hand side, adding those up, that's minus 5. So x is minus 5 divided by minus 2. So x is 5 over 2. And then to find y, just substitute that value of x back in to one of the first two equations. I'll take the first one. So minus 0.4 x plus 0.8y is minus 1.4. So put x up to 5 over 2 in. So minus 0.4 times 5 over 2. That's minus 1. That's minus 1 plus 0.8y is minus 1.4. So 0.8y equals, take the minus 1 over, and that becomes minus 0.4. So y is minus 0.4 over 0.8. That's minus a half. So the fixed point then is a coordinate. Fixed point, coordinate 5 over 2 minus 1 over 2.